Bird strikes are a reality of aviation. I mean, we share the air with them, so inevitably bird strikes are going to happen. But as a pilot, I wanted to better understand my realistic risk of hitting a bird and understanding statistically what happens should that occur. So I studied for many hours to put this resource together that hopefully gives you the pertinent information you need to know about bird strikes. Now you should know I'm not just making this data up. There's so much information out there, but I really pulled all of the data in this video from two primary sources. And the first one, and I'll link them below, but the first one is a 120 plus page report by the FAA where they studied all the bird strike data that they had from 1980 to 2018. And again, it's well over 100 pages. I read every single page of it and tried to pull out the most interesting and applicable excerpts. And then the second main resource was I found all of the slide decks, all of the presentations from the 2019 North American Bird Strike Conference, which was 3 days and 35 presentations spanning well over 1,000 PowerPoint slides. And I looked through every single last one of them. So between these two resources, I've learned a lot about bird strikes. I read a lot of information and tried to pull out the most pertinent facts. And I'm going to present them as succinctly as I can here in this video. So let's jump right in. So first, let's cover when are you most likely to encounter a bird strike? And this really is kind of three different sections. The first of which could be the time of year, so which month, then the time of day, and then the phase of flight. We're going to cover all three of those. So first, for the time of year, the FAA put out some really good data that across the board for North America, they looked at month over month, when are you most likely to encounter bird strikes? And so throwing up the chart here, you can see the highest likelihood period is July through October. About 53% of bird strikes in their data set occurred during those months. This is definitely the peak. There's a second peak kind of in May, but then the low season, the lowest probability is December through February, where only about 10% of strikes occur. So what about time of day? Are you more likely during the day or during nighttime operations to encounter a bird strike? Well, the FAA's data shows that about 63% of all of their bird strikes occurred during the day, whereas about 29% occurred during the nighttime, and the remainder just being either at dusk or at dawn. And so during nighttime, it might intuitively be easy to think, well, during the night, we have our lights on. It might be easier for birds to see the aircraft, etc. You have your landing light on, so they can surely see that coming, right? But there was a really interesting study that I found in these conference slides that was done by the United States Air Force and Clemson University, and they found this, I'll quote it. They said that birds do not make evasive maneuvers to avoid approaching aircraft with their landing lights on, which really means we need to be able to update our technology to help birds see us better. They might not be able to just see the landing light. I mean, they do, but this study found conclusively there wasn't statistical evidence to suggest that birds see the landing light and move out of the way accordingly. So there's some really interesting technology that's being developed to help bird avoidance at night. We'll cover that in just a few moments. So finishing off, when are you most likely to hit a bird? Let's cover the phase of flight. What part of the flight are you most likely to encounter a bird strike? So the FAA has some interesting data here, and they show that about 34% of all bird strikes occurred on the takeoff run or the landing roll while you're still on the ground. About 17% occurred while you were on the climb and the departure phase of the flight. But interestingly, about 42% of all bird strikes occurred on the approach. Now, why would the approach percentages be so much higher than climb out? Isn't it kind of the same thing, but just in reverse? And the best I can figure, and my guess is on the approach, you're typically at lower levels for longer lengths of time than you are in the climb out. In the climb, they might just go ahead and give you clearance to a much higher altitude than the opposite happening when you're in approach. A lot of times you're low for quite a while. And as we'll see in a minute, the lower you are, usually the higher the likelihood of you encountering a bird is. So I think that's what's going on that data, but pretty interesting that they're so far apart. Okay, part two, where are we most likely to encounter a bird strike? We'll take this in three phases. So let's start with altitude. The general takeaway here is that bird strikes happen at pretty low altitudes, and the higher you are, the less likely you are to hit a bird. The FAA had some interesting data here in that about 41% of all strikes actually occurred on the ground. About 71% are less than 500 feet AGL, so how high you actually are above the ground, not above sea level, but above the ground. 82% are below 1500 AGL, 92% are below 3500 AGL, and 98% are below 7,500 feet AGL. So pretty much once you're in cruise, and even a 172 cruise, even if you're cruising at 5,000 feet, I mean, the vast majority of bird strikes are going to occur lower than that. So that's not to say that if you're flying really high, you're never going to encounter a bird. The FAA's data here showed that their highest recorded bird strike in that data set and time range was at 31,300 feet, which is really high. But in the 1970s in Africa, there was a reported bird strike where a vulture was hit at 37,000 feet. So the second part of where you most likely hit a bird comes down to airports. What are the airports with the most active bird strike encounters? So I looked through a bunch of data, and the number one contender for just the raw count of bird strikes is Denver, Colorado. Now, this isn't really necessarily the best way to look at it, just raw count, because airports that have more traffic have more chances to hit birds, so their raw count probably goes up. So really you need to look at it in terms of per operation or per the number of flights. And so the way this data set that I found in the conference was looking at it was out of every 10,000 flights or operations, how many bird strikes were there? So Denver is not in the top 5 when you look at it per 10,000 operations. So here are the top 5 airports. Number 5, coming in at 11.08 bird strikes per 10,000 operations, is Memphis, Tennessee. Number 4, with 11.42 bird strikes per 10,000 operations, is Evansville, Indiana. Number 3, making the podium with the bronze medal, with 12.11 bird strikes per 10,000 operations, is Dayton, Ohio. Number 2, with the bronze medal on the podium, at 14.84 bird strikes per 10,000 operations, my home state, McAllen, Texas. And number 1, the most bird strikes per 10,000 operations in this data set was Kansas City at 16.86 bird strikes per 10,000 operations. Okay, the last part of where we most likely to encounter a bird strike is what part of the airplane. Now, Boeing actually put out some pretty interesting information on this topic where they showed that about 21% of all bird strikes occurred on the nose and the windshield. About 44% occurred on the engine, one of the engines. About 31% occurred on the wing, and only about 4% occurred on the fuselage. Now, an interesting piece of this data is that the U.S. Department of Agriculture did a study where they found that a statistically significant portion of bird strikes were occurring more so on the left side of the aircraft than on the right side of the aircraft. Now, why would this be? Well, the scientists looked at it and they determined that the vision spectrum of these birds that they were analyzing made it so that they could see green light a little bit better than red light. Well, why do those colors matter? Well, they are the right and left, respectively, colors on aircraft wingtips. So you got a green light on the right side of the aircraft and you got a red light on the left side of the aircraft. So what they found is that the birds could see green light a little bit better than they could red because of their vision spectrum. So this study has really helped researchers understand bird strikes a little bit better and develop some pretty interesting technologies in the works to help avoid aircraft better, because it's not just that we can see aircraft well at night with the red, white, and green lights, and birds can too. That's not really necessarily the case. They found that there's certain colors they can see better and worse than others. Next is what types of birds are we most likely to encounter in a bird strike. So let's start with what birds are hit the most often. In 5th place is the horned lark. It only causes damage about 0.5% of the time. 4th place is the barn swallow. In 3rd place with the bronze medal is the American kestrel. In 2nd place is the killdeer. And in 1st place, causing damage 2.1% of the time, is the mourning dove. So you can see while these are most frequently hit, I mean, the percent of damage they cause is actually very, very low. And a lot of these are pretty small birds, but what about the big birds? How often do they cause damage? And here are some of the top 5 most damage-causing birds when they are hit, and no surprise, they're pretty large. So here's 5 of the top ones. The Canada goose causes damage about 48.7% of the time. A turkey vulture will cause damage just about 50% of the time. They're very large birds. A mallard causes damage about 20% of the time. A great blue heron is just shy of 19% of the time causing damage. And an osprey causes damage about 23% of the time. So what happens when we hit a bird? Well, I think a really important data point to start with is to understand that the overwhelming majority of bird strikes actually don't even cause damage. On the FAA's data set, overall about 7.5% of all recorded bird strikes cause damage, but even in the last few years, that average has been more like 4%. And so furthermore, not only do most bird strikes not cause damage to the aircraft, if you look at the fatality rate in the FAA's data set over 29 years, there were 14 different bird strike encounters that led to 33 fatalities. So obviously a very unfortunate event, but when you look at how much air travel has occurred over that 29-year period, bird strikes are really nothing to worry about, statistically speaking. If you look at what happened after the bird strike, the FAA's data says that about 55+% of the flights had no effect. So the bird strike had no effect on the flight. And what they mean by that is that, and the way they define it, is that the flight continued as scheduled. So they probably went to their destination and landed, although there could have been delays or other things that happened after landing, but it didn't cause like an emergency abortion of the flight or a landing, that sort of thing. Now, about 46% of the data was unknown here. So honestly, that's a pretty big hole. There could be a lot of different things that happened in that unknown, but I think more than likely that led to a favorable outcome because it would have been pretty noteworthy to document if there was a crash or they had to abort the flight or any number of negative results. I think that those probably would have come out of this data. So I'm leaning towards, and the commentary that I read around this report kind of leaned towards almost half of the results of the flight were unknown, but we tend to lean towards those actually being favorable outcomes. One last interesting data point on what happens when we hit birds is how much is this costing the industry? On a per bird strike basis, what does it cost when you hit a bird? So the FAA's data over 29 years suggests that it cost about $184,000 per bird strike. And yes, they did account for inflation over this data set, and most of that is going to be in repairs and maintenance and such. And there's about $25,000 of other costs. But just shy of $200K if you hit a bird. It's a really expensive problem for the airline industry that they're working really, really hard to solve. So in my research here, I found some really creative ways that the industry is trying to reduce bird strikes, but then a lot of it is centered around data, because without data, you can't make informed decisions on how and where and why to fight bird strikes. And so there's a huge push to gather the very best data to be able to inform those interventions. But let me start with some of the really cool ways I have found people trying to reduce bird encounters, bird strikes, and even just birds in the vicinity of the airport. There's some really cool things. So one of the most exciting things I found is actually a robotic falcon. And there's a couple different companies that do this, but it's basically like an RC airplane that looks like a falcon, and you get a guy that goes out to the airport and chases around birds because falcons are predatory animals. They often eat other birds. And so other birds recognize this because it looks just like a falcon. And so they can kind of herd these populations of birds off the vicinity of the airport. Another way to cut down on bird strikes actually has to do with the technology on board the aircraft. So like I was talking about earlier in that study that found that birds can see the green light a little bit better than they can the red light, it led scientists down a path to figure out what spectrum of light would be most optimal to put on aircraft so that they're more visible to birds. And so they're experimenting with different types of lighting systems that could be installed on aircraft so that birds could see them. So they're experimenting with a bunch of different spectrums of lights and purples and different things that could either be on perpetually for the aircraft. It could be coupled with the GPS and AVIAN radar to be flashing at certain times where they think there's more birds around. There could be all different kinds of applications, but the overall goal would be, let's just be more visible to birds so they can see us and avoid us. So speaking of AVIAN radar, yes, this is a real thing. You have radars starting to be installed on airports all over the world that are there to look for birds. And so this can serve a bunch of different purposes. I mean, one in general for just creating advisories to where controllers know that there are known flocks and quantities of birds in the vicinity, and they can give the pilots on board aircraft advisories to just know this is present. But then even more advanced applications are being developed where this information from the AVIAN radars can be coupled with information on aircraft. So if we know the trajectory of an aircraft and we know the estimated trajectory of a flock of birds, then maybe we can intervene before they would ever meet, either via a delayed takeoff clearance or through radar vectors or what have you. But we can be more proactive about trying to see these collisions before they might occur and intervene appropriately. I think it's a really cool adaptation of currently existing technology. Another technology being developed is a laser sensor to better understand if and when a bird is ingested into a jet engine. Now, a portion of these occurrences really go undetected, and that can be the most problematic and scary of all, because if you have internal damage to a jet engine that might not manifest itself for some time, but is unbeknownst to the operators, that can be a really scary situation. And so almost like, this is going to be a really dumbed down example for you scientists out there, so I'm sorry if this is offensive, but kind of like how your garage works, where there's two lasers kind of pointing together, and if that beam is broken, then you assume, okay, your kid's in the way or something, you'll stop the garage door. Similar technology where they can understand if that plane is broken, not the airplane, but the laser plane, if that's broken or interrupted, then we know something was ingested and they can intervene appropriately. So there's a lot of really cool things. I mean, even pyrotechnics and lasers and trained dogs and stuff are going on airfields. And then, even simple things like just taking inventory of what types of environments are being grown around the airport. Are they attracting bird activity? Is it a deterrent, etc.? Let's not have things in and around the airport that are going to attract mass flocks of birds. I mean, that's a very straightforward approach, but it's one that shouldn't be ignored. So all of those things are being taken into consideration by the aviation community to try to cut down on bird strikes. So there are a lot of really cool technologies being implemented on this topic. I just scratched the surface of them. But again, as I mentioned earlier, none of this matters without really good data to inform decisions. And so there's a couple of cool ways that the aviation community is trying to better gather data on bird strikes. So the first has been just moving to an online format to report bird strikes. Instead of it being an old paper format, something you have to mail in through snail mail, there's an online way to quickly and easily report bird strikes. So if you have one, definitely go to the FAA's website. You can just Google it. It's pretty easy to find, and they have a portal for you there. But there's other higher tech ways that the aviation community is trying to gather data on birds and everything related to bird strikes. Machine learning is becoming a big portion of this. So even applications like airports taking tens of thousands of photos of their bird population and teaching computers to understand what's a bird versus what's a stick or some garbage or something on the ground, to understand how many birds are in the area, what their movements are, what intervention strategies are doing to that bird population, etc. And if we can harvest tens of thousands of pictures and have computers really digest that, then that makes data gathering way more cost effective, way more scalable. And again, that can feed back into the intervention strategies and make them all the more effective. And then you have entire dedicated teams and personnel at major airlines, like Alaska Airlines Group is really transparent about the data they're gathering. This is a very big push for them to better understand the bird strikes that they themselves encounter in their airlines, and then also working with the government to help just add data to that data set and better process that to have better interventions, because again, they're all looking at it from a safety, efficiency, and cost savings perspective. So there is a ton of different groups really all trying to solve this problem. And I didn't really know any of that. I just wanted some data to better inform myself as a pilot on bird strikes. And then I found this entire movement where there's all these conferences and crazy amounts of data sets. So this is very much in process, and it's a really interesting thing to witness in aviation. So I put a lot of energy and a ton of research into this video. I hope it shows, but really more than anything, I hope it was helpful to you as a pilot or as an aspiring pilot or someone who rides commercial airliners. It's relevant to all of us. So I'm doing my very best to try to keep the bar high for quality of content on this channel. I'm doing my very best to post weekly, but I hope you'll subscribe so that you never miss a video, and sign up for notifications so you'll get a quick email whenever we hit the post button. But anyways, thanks for joining me today, and we'll see you guys in the next video.